Hello everyone, welcome to CS2211 course, and I'm Zen Andrei Obrero, who's going to be your instructor for this lecture. In this video, we are going to study about DFA minimization, or minimization of deterministic finite automata. But first, what is minimization of DFA and why is it required? Minimization of DFA is required to obtain the minimal version of any DFA which consists of minimum number of states possible. So, what does this mean? Let us take an example to explain this definition. So, take a look of this DFA. Here, we can see that we have 6 states, and those are Qs of 0, Qs of 1, Qs of 2, Qs of 3, Qs of 4, and Qs of 5. Our task is to minimize this DFA with minimum number of states possible. The first step when minimizing our DFA is to draw the states transition table. In this table, we can see the states on the side and the input of zeros and 1 on the top. By looking at the graph earlier, we can see which states releases an input. We can see that the state Q0 releases an input of 0 in Q1 and releases an input of 1 in Q3. Then at the state of Q1, it releases an input of 0 in Q2 and releases an input of 1 in Q5, and so on. After we finish the transition table, we can now proceed to minimize the DFA using the equivalence theorem, where we will determine the equivalence of states to each other. First, we will start at the equivalence of 0, where we will group the final states and non-final states. So our 0 equivalence should look like this. Here we have 3 non-final states on set 1 and 3 final states on set 2. To determine the equivalence of each states, we need the transition table earlier. Next, we will proceed to 1 equivalence, where we will determine the equivalency of each of other states by looking at the previous equivalence. So our 1 equivalence should look like this. Here we can see that Q5 is separated on set 1. That is because Q0 and Q3 is not equivalence on Q5. And after that, we will proceed this method until the current equivalence is the same as the previous one. On the last equivalence, we can see that there is no changes between the previous one and the current one. So that's when we will stop. After we get the final result of the equivalence of the DFA is now minimized. And after that, we are now going to graph the minimized version of the DFA. The minimized version of our DFA will be having 3 states only. And so the graph of the minimized version of our DFA should look like this. So that would be all for this lecture. Thank you for joining me, and I hope you learned something from today.